Good morning, good afternoon, good evening, everyone, depending on where you're tuning in from. Thanks again for joining us for another DevTalk. So in July's edition, we have one of our senior software engineers with us today. We're talking all about implementing security on Android devices. So just before we get started, we have a few sort of housekeeping rules and things to cover just before we get into the meat of the content. So if you could go to the next slide, please, Sarah. Thank you. So as always, we encourage you to become part of our developer community if you're not already. So make sure to register and take a look at our redesigned developer portal over at developer.zebra.com. You can also connect with us through our social media channels under Zebra Developers, and we also have our GitHub account at Zebra Devs as well. So please do make sure to come along and join our community and participate in our discussions and review all the content that we put out for you guys. If you could just go to the next slide, please. Okay, so just to give you a quick heads up of some of the events that we have coming up, the main one that we wanted to bring to your attention is DevCon, which is coming up very soon now. So we'll be having our in-person conference in Madrid between September 13th and 15th. We're really excited for this. It's been a long time planning. It's the first time that we've been able to get back in person together since 2019 for obvious reasons. We'll have a ton of breakout content in there, just like dev talks like these, as well as keynotes from exciting presenters from Google, as well as DeepSense.ai, and also some of our executive leadership team here, including Tom Bianculli, our CTO. So we do have a discounted early bird ticket price until the end of the month. So you have a couple of days to get back in there and secure your tickets. It'll be $149 if you get that early bird discount. So great value for money there. Lastly, we'll also be over at DroidCon London later this year in October. So please do make sure to come and check us out there if you happen to be in the area. So just before I hand over to Sairam to get into the content today, I just wanted to remind you that all of these sessions will be recorded and they're uploaded to our YouTube channel. So you can just look Zebra Dev Talks up on YouTube and you'll see all of our previous Dev Talks, including this one in a couple of weeks. And questions will be covered at the end. So if you have any questions, use the Q&A bar on the sidebar and we'll get through to those on a first come, first served basis at the end of the presentation. So that's enough from me. Thank you all for your time, and I'll hand over to Sairam now for the exciting part of the presentation. Thanks, everyone. And Sairam, the floor is yours.
Thank you. Hi, all. This is Sairam Koturi, Principal Engineer in Zebra Technologies, overseeing security architecture across Zebra Enterprise mobile computing devices. Today, I'm going to cover best practices or how to implement security of Android applications on Zebra mobile computers. So this is my agenda that I'm going to cover today. As we all know that Android applications are increasingly being targeted by attackers. So in order to protect your applications from attack, it is important to secure and implement security controls around these applications. So I'm going to cover today exploring data classifications and risk assessment, worry of threat modeling, leveraging a couple of tools like Stride and Drag, accessing device identifiers through Zebra APIs, and any other further questions that we have as part of this one. Application security normally refers to a practice of protecting software from various threats and vulnerabilities. So data classification and risk assessments are essential components of application security. So to start with data classification, it is a process of categorizing the data based on its sensitivity and criticality. How do I identify and classify these protected data? There are different ways. So you can classify it as a protected, unprotected, public, or open. So you can classify based on the nature of the data you're collecting or your application is collecting. Is it related to an IP, or it is a personal information, or personal medical records the government records. So those are all the classifications of the data. If the collected data is exposed to a third party or an attacker, what bad they can do it. That's assessment we have to do it. Once you have the assessment, now you need to identify the risk associated with that one. So the primary goal is to understand likelihood and the potential impact of these risks to make informed decisions about how to mitigate them properly. So once you identify the associated risks, the last step could be you have to implement appropriate security controls. This by includes data encryption or data backup and recovery, or couple of access controls where it suits your application requirements. Okay. Next is trust risks modeling. It is an important aspect of the security development lifecycle, which is a process aiming to build better and more secure systems or software. In simple terms, threat risk modeling is a method to use it to identify important things like assets, analyze possible dangers, and take steps to reduce those risks. The process mainly involves in different steps. Figuring out what we want to protect, like what is our security objectives, looking closely at the different parts of the application, finding potential dangers and weaknesses, understanding that each risk can affect assets differently because the asset you collected it will have different kind of risks associated with that each threat you identified it. We at Zebra use DRAD and stride analysis for identification of threats and risk ratings. That's what I'm going to talk about in upcoming slides. Once you have vulnerabilities are distinguished, so we use stride is the another one tool where we will be using to classification of the threats. Stride normally stands for spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privileges. So basically this is using this framework, application developers can classify the threats each application is exposing it. So spoofing means it is an impact related to authentication, and tampering is which is more related to the integrity. Repudiation is means impact onto the non-repudiation. Like information disclosure means critical information like your personal information, sensitive data disclosure. And denial of service is availability for application if any attack happened to your application. Elevation of privileges means it's the authorization point of view. So even though you have a legitimate access, because your application being attacked, you cannot get access. So overall, to follow the stride, first you need to decompose your system into relevant components and analyze each component for susceptibility and mitigate the threats. Once you identify the threats, the next step is how do we rate those threats. So DRAD is another model used to rate your risk. So DRAD now represents damage potential, reproducibility, exploitability, affected users, discoverability. It's called DRAD. Each of these rated onto a scale of 1 to 3. 1 is the least severe and 3 is being the highest. Overall risk is calculated based on the averaging of these each factors. This tool is used basically for the prioritizing the security threats. So once we understand the severity of each threat, your application organization can focus on the resources and mitigating these most serious threats. So overall, Stride is more focused towards identification of the threats. DRED is more focused towards the assessing the severity of the threats. Let's take an example. If we observe, right, starting Android 10, Google imposed restrictions on device identifier access. The reason for this enforcement is to protect user privacy and prevent security vulnerabilities. Because once serial number is out, anybody can track you and somebody can impersonate that the device is yours, even that is not you, even though if it is somebody's. So it's not only the serial number, Google restrictions imposed on IMEI and Bluetooth on different static unmodified identifiers. They stopped allowing to access by Angry Bird kind of applications. So taking the example of earlier, right? Okay. If I want to, what is the reason for restrictions for this device identifiers? So if you look at the spoofing identity, if we apply the Stride model, right? Spoofing identity. So if my serial number is disclosed, any third-party application can impersonate as a specific device user. So it will lead to unauthorized access to the sensitive information or resource associated with the device or a specific user. For example, an attacker can spoof the serial number of a legitimate device in order to gain an access to a corporate network. Tampering data. If an attacker can tamper your serial number, he will start tracking your identification or tracking of the device. So it will be used to misuse or create a confusion. So if you can able to attack or modify your serial number, you can do many different things that you may not be aware of it. Because once you have serial number, right, you can cause denial of service, which is one of the Stride models, and you can disclose sensitive information, and you can elevate a couple of privileges. So once we have the threats in place, now we need to analyze the risks associated with that one. We need to rate these risks. What will happen if a serial number is exposed? What kind of risk is this? Because we discussed it is impersonating or pretending that somebody is as you, or it will be allowing to track your identity, which is high in nature. Can I reproduce it? It is little difficult because unless you have the device with you and you found a weakness in the system, it is a little difficult. The rating is low. Exploitability, yes, you should have some specific knowledge. You should be a advanced developer. Then you can exploit this vulnerability. Affected users, yes, definitely. It is affecting most of the users because if it is elevated or if it is exposed, Angry Birds can control your device. Discoverability, yeah, it's not readily discoverable, but if a advanced user can inspect a device, you can always get to know that what kind of thing you can do with your system. So overall rating, if you look at here, it is 11. As per the OWSP rating system, it is falling under the medium risk. That's the reason Google thought it is exposing device identifiers in controlled manner via profile or device owner, or they're trusting carriers like Verizon, AT&T. They can get the device serial number. Other than that, they're imposing it with the permissions called system privileges. Okay, so because Google enforced restrictions on device identifiers, so what does it mean is developers are expected to use depending on the profile owner, device owner, or it should be a carrier. Or if you are a OEM, you need to include a read privilege state, which is the signing privileges. So definitely third-party applications cannot get this serial number at all. Then why Zebra is exposing this? Because Google thought carriers in consumer point of view. But in consumer point of view, because it's not required by every customer, every application, every user to know their serial number via programmatically. If you have a device in your hand, you can always get your serial number with you. Whereas in application, enterprise kind of thing, right? It is used device management, security, licensing, and compliance purposes. It is important in enterprise use cases than a consumer centric. So Zebra implemented or exposing these APIs in a balanced method where it is giving more powers to the admin than what it has today by Google, as well providing a mechanism to the developers how to get this device identifier by a certain mechanism using a proprietary implementation by Zebra. So Zebra solution for this one is via OEM Info. We are exposing these interfaces. OEM Info is protected, so permissions must be granted before you get access to this one. There are some process involved with it. So what are those processes? Access the device identifier using OEM Info. So there are a couple of steps or sample code is involved. There are some proprietary permissions need to be defined. There is a content providers using OEM Info exposed. Once you have implementation in your application needs to get granted by an admin. Then only you can retrieve the device identifiers to your application. Let's look on to the how to access or implement these identifiers. So you can grant your application in the multiple ways using StageNow or an EMM or EMDK profile manager. So now how do I access device identifiers using OEM Info, which is a Zebra proprietary solution? So in your manifest, first you need to declare a permission called provider read and content provider, the query package, because to get the authority and provider API using the following examples. Yes, I'm going to provide it. But in your manifest, you need to include these two read permissions. We have Zebra exposed a couple of URIs. One particular thing is for build serial. This is what we are talking about. One of the device identifier. You can create an instance of this one, and you can create a content provider, get the cursors out of it, and with these three steps which included in your application, now your application is ready to get the device identifier, particularly build serial number. Once your implementation is completed, Next, how do I grant these permissions into the applications? So I'm using a stage now for a demonstration purpose. So this is how stage now UI looks like. In this, you have to provide service access action as allow caller to call a specific service. And service identifier, in this case, it is a bill serial number you have to provide. Caller package name of our application, test application, you have to provide it. And caller signature, this is your application signing certificate. So every application is signed with some certificate. So you need to extract signing certificate of our application. Zebra is exposing a tool to extract the signing certificate. So this is a sample command. You can extract certificate of your application and provide in the stage note tool. Once you provide, you will see a barcode generation screen. So once I scan this one using stage now tool on device, then if I launch my application, I should be able to see the serial number and IMEI also based on your content URI provided. You can see it. If your application not follow the second step, like granting of the permission, you will get a null cursor. That means it will return an empty value because the application is not having any permissions. So you can always write your application such a way that if you get a null permission, just to make sure that what's going wrong, you can simulate something, some error like your OEM, this application doesn't have an access call to OEM service. So that users will know that why this is not working. Okay, in summary, data classification. So we discussed about data classification. Basically, it is talking about how to identify different types of data that within an application and assigning a sensitivity or protection level for each of the classified data, and how to implement that classification policies and procedures, and threat risk assessment. How do we, once we have identified threats, how do we assess these risks using a couple of models like STRIDE and DREAD models. Once you have these in place, even though you have a mechanism to extract data, in the example that Zebra is exposing OEM Info, just because you have a serial number, it doesn't mean that you should be logging into the, this is still is the sensitive information, but it is supposed to be used by your application only. So still you need to protect this data which is collected and by means of a couple of security controls, whether encryption or whatever it is suits in your application context. So in upcoming sessions, we'll be covering data and secrets management, which is only focusing on scope of storage, data at rest and data in motion. It is called DAR and DIM, credential management. And the important thing is interface protection. How do you protect interfaces? What is like private and public? And obfuscation, like protecting your code from the reverse engineering. So that's all I have for this session. This is to set a context on how to implement security in your applications or best practice, security best practices in implementing application for Zebra devices. So any questions around this one?
Okay, Sarah, thank you very much for that presentation. Much appreciated. Doesn't look like we have any questions through just now. We do have your Outlook reminders on the screen though, so you might want to remove those. Just clear those out. But aside from that, no questions. There was just one thing that I wanted to note personally. So I know that you talked quite a bit about the OEM Info content provider and accessing the device serial numbers. So I just wanted to bring to everyone's attention that we have quite a bit of sample code and documentation about that, not least on TechDocs, but we also have a couple of blogs on the developer portal as well. And you can also check out some sample code on Zebra Devs as well. So for lots of different use cases, we have a wrapper that makes it easier. We have a utility that will save those numbers to a file, so it can be pulled by an MVM. And we also just have a sort of a basic demo as well to just pull the identifiers onto the UI of the device as well. So just something to bear in mind there. So I was hoping maybe that some questions would come through during my little filler there, but it doesn't look like they have. So I think we'll bring this session to a close. So just to remind you, we will be posting this onto YouTube in a couple of weeks' time. So just search DevTalks, Zebra DevTalks on YouTube, and you should be able to access this recording should you want to listen back to it. Otherwise, we'll see you next time. And just once again, please make sure to check out DevCon, and we hope to see you there as well, if possible, in September. So thanks, everyone, and thanks, Sarem, again for your presentation. We'll see you next time.